Hello guys, my name is Newman Okerafo, and today I want to be talking about random function as a dangerous random number generator for cryptography. But before I go into details, I want to quickly define what a random number is. A random number is a number selected from a group of numbers with equal probability of being selected from a large set of numbers or through a mathematical algorithm. Basically, there are two types of random number generator, which include the true random number generators, which is abbreviated as TRNG, and the pseudo-random number generators, which is abbreviated as the PRNG. However, my presentation is going to be focused on the pseudo-random number generators, but I want to quickly give an overview of the true random number generators. The true random number generators is best defined by the two properties: physical process. A physical process means that a true random number generator extracts its randomness through physical processes like the free running oscillation in electronics and noise. And secondly, a true random number generator is really non-deterministic, which means that the sequence of numbers generated by a true random number generator is unpredictable. The pattern of distribution is unpredictable by anyone. Okay, the pseudo random number generators is a different type of random number generators that actually depend on mathematical algorithm. And the numbers generated by these algorithms are not really random in real sense, but they appear to be random, and they are deterministic as they follow a set of pattern or distribution. So, like I said earlier, a pseudo-random number generator can be a mathematical formula that produces a sequence of deterministic and periodic numbers. And we have a couple of examples of a pseudo-random number generator. For example, we have a list here, and the first one here is the rand function in C++. We have the nestInt in Java, and we have the randInt function in Python. And we also have the randy, randn, and the rand function in MATLAB. And we also have Mersenne Twister is really a different type of pseudo random number generator because it's special because it's really very fast, and in fact most people consider it to be a true random number generator because of the period and the range of numbers it produces. So let's go into the topic of today, which is rand function. Rand function is used by many people as a source of random numbers, and there is nothing wrong with the rand function, but the problem with the rand function is what it does and how it does it. So rand function is often used in places where it should not be considered as option, and the worst victim of rand function is cryptography. I say this because according to August Kirchhoff's principle, cryptographic systems should be secure even if everything about the system except the key is in public knowledge. So due to Kirchhoff's principle, the definition of a random number generator suitable for cryptography must include that even if every detail is known about the generator, it still must produce totally unpredictable bits. But as we all know, RAND fails in this because anyone could get hold of the RAND function algorithm and edit it, and influence the outcome of the RAND function. So let's dig deeper into RAND function by discussing about some of the properties. The first property of the RAND function that I want to talk about is the range. RAND function, returns a limited number of numbers, and this range is basically between 0 and RAND max. Okay, let me quickly show you what RAND max is. RAND max is a variable in C++. As you can see here, I have a C++ program. I have these are the header files, IOStream, standard C standard library, and the CTime. These are libraries that you have to work with, when you're dealing with RAND function. But I'm not here to talk about C++. I just want to show you what RAND max is. It's just a variable that when you pass it through a program, it returns an integer, which is 32767. So if you look at this single line of code, you see here, I said cout RAND max is, this is just a string. Then when you pass the RAND max right here, and call this very program, it's going to output RAND max is 32767. I just want to show you that RAND max is not a strange but a regular C++ variable that outputs this integer 32767. Okay, that takes us to the period of RAND function. The period of RAND function is typically between it's actually 2 raised to the power 32 minus 1. This value is like 4.3 billion. One might ask, what is period? Period is just the maximum number after which the RAND function starts to repeat itself. So after having a sequence of 4.3 billion, the RAND function begins to repeat the sequence. Well, you might argue that is a big one that is not still okay for RAND function, especially when you are working in cryptography that demands high bit numbers. So having 4.3 billion period actually disqualifies RAND function as a true random number generator. So it should be avoided. That's the truth. So let me talk about the next property, which is the quality. Well, you might actually define quality in different ways, but it is an obvious fact that the RAND function has always been implemented poorly, where the numbers it's generated seem to be predictable and at worst not random. So like I said before, RAND function is wrongly implemented, especially when programmers use high bits to adjust the range. They do this just to actually get what they want, but the implication is really disastrous. Let me show an example. Right here, this is a program to simulate a dice roll. In this program, you have the RAND function, and the modulo operator, just to actually produce a sequence of 1 to 6, and the modulo operator is actually not the best to be used with RAND because it actually affects the distribution of a RAND function. So like here, when you do modulo 6 on this RAND function, and add 1 just to have the sequence between 1 and 6. If you call this function here, you have something like this: 5, 2, 5, 5, 5, 1. Right here you have 4 different 5, 1, 2, 3, 4, in a sequence of 6 numbers. So really, this is not really random. So one could actually predict the outcome of this of this output, So it is really dangerous thing to do, to use modular operator with rand just to have a particular sequence of number, because this really destroys the distribution of a rand function. So let me quickly talk about distribution, which is another property of the rand function. Like I said earlier, the rand function is expected to return numbers which are in a given range, in equal distribution. So the distribution of rand actually means that the numbers in the range has equal probability of being generated for any rand function call, and the numbers distribution of rand function makes the sequence of the numbers generated to look random. So adjusting the range makes the rand algorithm to forgo the equal probability of each number to be displayed. So I'm actually trying to make sure that I cover this slides before my time. So let me quickly go into this. It's same as the previous program that I showed you in slide 12. It's right here. So let's quickly go into seeding the rand. Seeding has an effect on rand function if the argument is a time function. When you use a singular value, like a singular integer, to seed a rand, to seed the x rand function, it really has no impact or influence on the rand function because it keeps producing that set of sequence whenever that very number is passed as the argument to the x rand function. But for you to have influence on the rand function, you have to pass the time function into the x rand function, for you to have a series of random sequence produced by the rand function. So the time function is actually a function, when used as argument in x rand function, it gives the rand function the functionality of a true random number generator as the time input changes. So I'm really rushing to make sure that I cover these slides. However, like I said before, the time function returns the number of seconds, since midnight January 1970. So this ensures that the numbers generated by the rand will now seem to be truly random, unless it is called again within the same second. So let me go into conclusion. So obviously, random number is really essential in cryptography and Monte Carlo calculations, numerical simulations, and also in lottery. In fact, it is really, really essential in everyday life because we depend on encryption, we depend on, numeric simulations just to survive in life. So for this reason, we use random numbers in mobile communications, in email access, in electronic banking, in ATMs, point of sale, a lot of things, So I'm gonna stop here for today, and I'm very happy I was able to cover these slides, but all this is gonna be on YouTube, so you can actually go on YouTube and replay it again to get the information in more details. So I'm very grateful you have the time to listen to this presentation. I just want to say thank you very much for listening. Thank you. Bye-bye.